Okay, now you might recall from that last lesson that we did not answer that challenge problem. There was a reason for that. I wasn't holding out on you. We just didn't know enough. So we're going to look at that same problem again. An object is dropped from the top of Pittsburgh's USX Towers, which is 841 feet tall. Okay, the height of the object after t seconds is given by the expression, that same expression, 841 minus 16t squared. And we want to know how long will it take the object to hit the ground. And we're going to round your answer to the nearest second. You know what? We still don't know enough. We almost do, but we're very, very, very close, because let's take a look at what that problem said for a second. We know that 841 minus 16t squared, we said yesterday, if it hits the ground, the height is 0. That's what we were trying to solve. Well, this is not a linear equation. This is actually called a quadratic equation. Now, I know that seems weird to you because quad means 4, but this is a quadratic equation. How do I know it's a quadratic equation? Because the exponent, or the degree of the expression, is a 2. Okay? All right. So a quadratic equation is defined above. It says a quadratic equation is an equation who can be written in the form of ax squared plus bx minus c equals 0. Okay? Where a cannot be 0. The reason a cannot be 0 is because if a is 0, then this drops out. It's no longer quadratic. It's then linear again. Okay? Now, you need to understand that a is always the coefficient of the x squared, or the quadratic term, and this is on that slide or in your workbook. B is the coefficient of the linear, or the x to the first power term. C is the constant term. Okay? So in a problem like this, 3x squared minus 7x plus 2 equals 0. Okay, that's a quadratic equation. Okay, and it's in standard form when it's in this form. That means set to 0. That means everything is on one side, zeros on the other. Unlike linear equation will want everything, all the variables on one side, numbers on the other. That's not what we want here. Here we want every term on one side, but 0 on the other. In this problem, a would be 3, b would be -7, c would be 2, because a is the coefficient of the square term, b is the coefficient of the linear term, which is -7, and c is the constant term, which is 2. We're going to take a closer look at this when we learn how to solve them. Okay, so the first thing we need to do is we need to understand the degree of the equations. When a degree of 2, it's called quadratic, okay? And when it's 3, it's called cubic, and then there's other, it could be a degree of 4, it could be a degree of 5. They don't have names, or at least we don't care about those names, okay? So let's take a look at this next slide. I think we stated that when we talked about the degree of an equation, the reason it was important is because it tells us how many solutions the equation has. So let's take a look at this. Okay. 3y squared minus 4y plus 1 equals 0. This is a quadratic equation because its degree is 2. So the degree of this is 2. That's all we want here. And just so you know, this is standard form for this, because standard form means everything on one side, 0 on the other. Okay? And the a term would be 3 if we care. The b term is -4. The c term is 1. Sometimes that's important. Okay? So that degree is 2. Here, the degree is also 2. Okay, because the degree of this is 2. So here we go. That's all we care about. So this would also be considered a quadratic equation. If you care, I care, but if you care, okay, we can write this in standard form. Standard form for this would be that that everything's on one side, zeros on the other. So standard form would be to subtract 4 and get a squared minus 4 equals 0. That's not part of the question, but it's important to understand that's how you get standard form. Okay, let's take a look at this. This one, the degree of this is 1, the degree of this is 0. I don't have to worry about those numbers. Okay, so the degree here is 1. So I know that these two will have 2 answers, okay, or solutions, and this will have 1 solution. Okay, take a look at this one. This one is written differently. This one is written in factors when these were all written as terms here. Okay? You have to be careful. If you remember when we did a degree, it had to be simplified. If we simplify this, if we FOILed it or distributed it, we would get here, and I'm not going to do the whole thing, but we would get 3x squared. Okay? So that degree is also 2. Okay? Take a look down here. If when we look down here, this is also a degree of 2, because this degree is 2, this degree is 1, so the whole degree is 2. So the degree is 2. Consider a quadratic equation, and if we care about standard form, we could go 10x squared equals 4x and just subtract 4x and get 10x squared minus 4x equals 0. Okay, and that would be standard form. Notice you have no c term. A is the coefficient of the square term, so a would be 10. B is the coefficient of the linear term, so b would be negative 4. And there is no constant term. We're not looking at the 0. There is no constant term, so the constant term is 0. If you care, I care. Okay, take a look at this, and this is really easy to multiply, so I'm going to multiply it through. This is 2x cubed plus x squared, and that equals 0. Okay, this is not quadratic. This degree is 3, and it's only quadratic if the degree is 2. So this degree is 2. I'm sorry, this degree is 3, and if you care, it's called a cubic equation, and it's got 3 solutions. So all we care about right now is, can we find the degree of it? Okay, I have a deal for you. I'm going to offer you to pick any baseball team you want, follow them the entire season, and at the end of the season, I will give you some money. Ready? You can pick, but the product of the runs they scored through the whole season or the sum. So here's what I mean. Let's say you pick the Mets. All right, I'm sorry. But I'm from New York. Okay, let's say I know I should have said Yankees, but my brother was a Yankee fan, which makes me not want to be a Yankee fan. Anyway, so let's say we pick the Mets. And let's say the first game the Mets score, stop thinking, it's 0. Okay, let's say the first game the Mets score 3 runs. And then they score 7 runs. And then they score 2 runs. And then they get blown out, shut out. They score 0. And then they score 8. And blah, 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 blah. Okay? You can either have the product of what they score, or you can have the sum of what they score at the end of the season. Okay? Which would you choose? Here's the deal, but remember, the deal is that some money is better than no money. So you don't want to be locked out of money altogether. If that was the deal, which would you pick? Think about it. Really think about it. Okay, I hope you're done thinking about it. Here's the deal. You might say product because, wow, 3 times 7, I already have $21. Times 2, I have $42. Oh, and then I have to multiply it by 8. But what happens here? If they get shut out, you are screwed. It doesn't matter if they score 28 the next game because 2 times 0, all of this, 42 times 0 is 0. Times 28, you still got nothing. Nothing. At least if I have to add these numbers, I will still get something. It may not be as much, but I will get something. So I think I would take the sum, which brings us to the fact that of the zero factor property. Okay? If I have 2 factors, any 2 factors, I'm going to call them A and B. So I'm going to say if A times B equals 0, I bet you there's something you know about A and or B. Think about it. If A times B is 0, well, then I know either A has to be 0 or B has to be 0. Maybe they're both 0. That's a really silly question. But one of them must be 0. At least one must be 0. Okay, now notice what we have, because this is really, you're going, why is she talking so much about this? What is the importance of this? I'll tell you. Okay, see what we have here. We have factors are equal to 0. Once you have factors are equal to 0, that tells me that means that at least one of the factors, you're hearing me again, right? At least one of the factors is 0. That's not true for anything else we do. For instance, if A times B equals 6, we don't know anything about A or B. Maybe A is 6, maybe B is 1. Maybe A is 2, maybe B is 3. Maybe A is negative 2, maybe B is negative 3. Maybe A is 1/2, maybe B is 12. Get my drift? Okay, so we know nothing. Nothing. And if A plus B is 0, we don't really know anything there either. We know they're opposites because the sum of opposites are 0, but I don't know for sure what one of these are. So it's only when we have this property that I know that at least one of my factors are 0. That's extremely, extremely important. Let's see why it's so important. Remember what we just said? We just said if you have factors equal to 0, we know at least one factor is 0. Look what we have. Factors equal to 0. We have this factor, y minus 1, and we have this factor, y plus 3.5. In order for this whole product to be 0, at least one of these must be 0. So watch what we have to do. So if we have factors equal to 0, we know that means one of the factors is 0 or the other factor is 0. So that's all you have to do here. So y minus 1 equals 0. Now I'm just solving that. Y equals 1. And then we solve this, 3.5 minus 3.5 and we get y equals negative 3.5. Now, if you check this, and I'm not going to do the check, I'm just going to show you, if you do check this, there's actually two checks. You don't put 1 in here and negative 3.5 in here. You put 1 in for both these y's, and then you put negative 3.5 in for both these y's. Let me talk you through the check. Okay, if you put 1 in here, that's 1 minus 1. 1 minus 1 is 0. Then I don't really care what this is, because 0 times 1 plus 3.5 is 0 times 4.5, which is still 0. Same thing here. If I put negative 3.5 here, that's negative 3.5 minus 1, which is negative 4.5. But here, negative 3.5 plus 3.5 is 0. So we have negative 4.5 times 0, which is still 0. So the point is, this goes in for both the y's, then this goes in for both the y's. But it makes sense, because this guy makes this 0, so it'll make the whole product 0. This guy makes this 0, makes the whole product 0. Very simple. Why do we get two answers? I know you know. Because the degree is 2. If I went to multiply this, I would get y times y, or y squared. The degree is 2, which makes it a quadratic equation. Let's take a look at this one. Okay, two factors again. Two factors equal to 0. That's what we're looking for. That's the pattern we like. Why do we like that pattern? Because when we have factors equal to 0, not a number, but 0, that tells me, not any other number. 0 is a number. Not any other number, but 0, that tells me something. So I can go x equals 0, or 3x minus 1 equals 0. Well, x equals 0 was very nice. It's done for me. So that's one of my answers. 3x minus 1 equals 0. I'm going to have to add 1. Add 1. 3x equals 1. Divide by 3. This took a little longer. X equals 1/3. So I have two answers again. I have x equals 0, and I have x equals 1/3, and I am done there. Again, two checks. That would go in for 0 both places. Then 1/3 would go in for x both places here. Okay, so two different checks. All right, so that's number 2. And again, this would be quadratic if I multiplied it out. X times 3x is 3x squared. All right, this one looks like a bear. How many factors do you have here? I know what you're going to say. You're going to say that we have 3 factors. That's what you're going to say, right? Well, think again. We have 1, 2, 3, 4 factors. Okay, this is 2 times x times the quantity x minus 5 times the quantity x plus 1/2. So there's 4 factors here. Now I have to tell you, a lot of even textbooks do this as one factor. That is incorrect. You'll still get the correct answer, but it's incorrect math, because they're not understanding that these are truly 2 factors. They're just taking a shortcut. I don't like shortcuts. You know why I don't like shortcuts? Because later on when we do fractional algebraic fractions, that will screw you up, okay? So I'm going to take them individually. So there's 4 factors. So 2 equals 0, or x equals 0, or x minus 5 equals 0, or, running out of space, x plus 1/2 equals 0. Okay, 2 equals 0, let's talk about that. 2 equals 0, that's impossible. 2 can't equal 0. You might remember from a while ago, that's called a contradiction, okay? There's no variable dropped out, and this is a false statement, so there's no answer from that. That's what I call a garbage factor. That's my word, nobody else's. I don't think that's a real math word. Okay, but I don't like that one. X equals 0, yes, that's possible. Why is that one possible? That's possible because there's the variable. X can be 0. X minus 5 equals 0. I'm going to do these here because I'm running out of space. X minus 5 equals 0. I'm going to add 5. I'm going to add 5. X equals 5. So there's another answer. X plus 1/2 equals 0. Subtract 1/2. Subtract 1/2. X equals negative 1/2. Think about how many solutions we have. We have 1, 2, 3 solutions. Uh-oh. Why did we get 3? We got 3 because this would be a cubic equation if we multiplied this, because x times x would be x squared, times this would be 2x squared, 2x cubed, I'm sorry. X times x would be x squared, times 2x would be 2x cubed. So it's a cubic equation, which means we get 3 solutions. If you care, you can write these solutions in set notation. You would use a brace, you would use one of the numbers, then the other one. The order of them does not matter. And a brace means, and this is going to be important later, a brace means what you see is what you get, only these 2 numbers, okay, 1 and negative 3.5. Here my answers are 0 or 1/3, and here 0, 5, negative 1/2. They do not have to be in order for set notation. And that's it. That is an easy way to solve these equations. Why were these so easy? Because you had factors set equal to 0. If this was not a 0, it wouldn't have been this easy. If these were not factors, it wouldn't have been this easy. But it's because they're factors equal to 0. That's what made this important. All right, we're solving this one. And I don't put the instructions on the board because it wastes a little space and it's in your workbook and already on your slide. But this is to solve this equation. Let's talk about this equation. Before, we had factors equal to 0. That helped us out. These are not factors equal to 0. These are terms equal to 0. Well, we want factors. We don't want terms. We talked about that. If two numbers added together is 0, I don't know anything about that. I cannot use terms. I need factors. What will I do? What? Well, factor. That's why we spent a whole long time, a whole mod on factoring. We want to factor this. So the first thing you have to do when you solve these types of equations, let me talk about what type of equation this is. This happens to be a quadratic equation, but I'm actually talking about any equation whose degree is 2 or higher. Okay? On your notes on the slide it says procedure to solve quadratic equations, which is true, but it's also to solve the same procedure is used to solve even if this was a cubic, a 3, or a 4, or a 5. Okay? The first thing you're going to do is you're going to put the equation in standard form, and I'm not going to write it out because it's on the slide. But put the equation in standard form. That means set it to 0. So that's already done for you because it's already set to 0. But here's the point. I don't like that. I have to factor it. So that's step 2. Step 2 is we have to factor this equation. So we're going to do that. So we're going to go back to everything we learned about factoring. Step 1. Step 1, look for a GCF. So you can't do step 2, you can't do step 3, got to go to step 4. Count your terms. There are 3. That brings us, I believe, to 4B. Okay? 4B says make sure, well, we already know we're in standard form because we put it in standard form. Okay? So 4B says it's easy to factor if your leading term is positive, and it is. And now it says make 2 sets of parentheses. So we're going to do that. Don't forget equals 0. Don't forget that. I almost did. Okay, so now the deal is I look at my last sign. It's negative. It tells me my factors are different. Now I'm going to factor, remember, 2x squared. And the only factors of 2x squared are 2x and x. I'm going to factor 3, 3 and 1. Oh, this is going to make my life so easy. Not like 4,000 tries like yesterday. Okay, so we have 2x and x. Okay, I'm going to put a 1 here and a 3 here. I'm going to do this, watch. Positive 1x, negative 6x. Oh, very close. Very close. Because I have the right number. That's okay. We'll just change the signs. Now I'll get them. Okay, now we're good. Now what we're going to do is we're going to continue solving this. Step 3. Well, what do you think we do next? And how do we know there's a next? Yesterday we stopped here. We just factored. And we were done. Because yesterday we had expressions. Today we have equations that set equal to something. We're not done until we find x. Okay, so now we're going to set each factor equal to 0 based on that 0 factor property, that anything times 0 is 0, right? Because if this whole thing is 0, then I don't care what this is. My product will be 0. If this whole thing is 0, I don't care what this is. My whole product will be 0. 0 factor property. That's why this works. You shouldn't just do things because we ask you to. Though that would be nice. And if you do things because I just ask you to, talk to my daughter. I'll give you her phone number. Okay, here we go. We're going to solve these. Add 1. 2x equals 1. Divide by 2. X is 1/2. So that's one solution. Let's go here. Subtract 3. Subtract 3. X equals negative 3. And there's your 2 solutions, and it was a quadratic, and we have 2 solutions. And by the way, the check is optional, but you can absolutely do the check if you'd like. I'd like to check at least one of these. Let me check. I know what you want me to check. You want me to check 1/2. I will. I'll check 1/2. They both work, I promise, but I'll check 1/2. Okay. This is 2 over 1. 1/2 squared is 1 times 1, which is 1. 2 times 2, which is 4. plus, I'm going to put this over 1, 5 halves minus 3 equals 0. I'm going to reduce here. 2 goes into 2 once, 2 goes into 4 twice. This is 1 half plus 5 halves. Watch, this is so easy. Look, I'm so happy. This is 6 halves minus 3 equals 0. But what is 6 halves? 37. No, 6 halves is 2 into 6, which is 3, minus 3, which is 0, and that all checks. So you are done. That's one check. You're really not done. You really would check negative 3, but I promise you negative 3 does check. I'm going to leave the check to you. So those are your two solutions, 1 half, negative 3. If you want to write it in set notation, you can. So when I do these problems, I'm going to leave out the checks, okay? But know that you can check them. You just don't have to have two checks. All right? Let's revisit the challenge problem when we come back. All right, let's go finally to this challenge problem we've been working on since the last lesson. Okay, see, there really is a need to know this information so we can solve problems that we've never been able to solve before. Now you may be thinking, I don't care about this challenge problem, but in real life there might be a problem that you do care about that you need to know this information for. So let's take a look. Remember, we were dropping an object off this building, and this is t stood for time, and this whole equation told me the height off the ground the object was. And remember, we wanted to know how long will it take for the object to hit the ground. We talked about this in the last lesson, that if it hit the ground, that means it's not off the ground, so the height would be 0. So obviously we're solving this then. Awesome. Okay, we now know how to solve this. Let's talk about why we know how to solve this. Okay, I will. Okay, we know how to solve this because this is a quadratic equation. Okay, and we know what we have to do is we have to set it to 0, which it is, put it in standard form, but it's not in standard form, is it? So we have to go negative 16t squared. You know what's going on now, don't you? You feel it, right? You feel it? I feel it. Plus 841 equals 0. Yes, I have a rash. Okay, I really don't like that. I have a rash. Okay, so I'm going to factor this, and I'm going to factor out that negative. So step 1 is to take out a GCF. 841, it's not divisible by 4, and it's not divisible by 16. I'm just going to tell you that. I tried it on my calculator. I get a decimal number. So I'm going to factor out a negative 1 because I just don't like that negative. Okay, when I factor out a negative 1, that means I'm dividing by negative 1. All these signs are going to change. Minus 841 equals 0. Okay, now let's go back to something we learned in the last lesson. We have to go back into these parentheses, and we have to make sure this cannot be factored anymore. Well, if there's two terms, we have to check for, yes, the difference of two squares. So let's check this out. Now, I have to be honest. I had to check with my handy-dandy calculator. And my handy-dandy calculator told me that this is a perfect square. So here we go. So we have the square root of 16. What times itself is 16 squared? That's 4t and 4t. What times itself is 841? That was 29. My handy-dandy calculator told me that. Okay. 29. Okay. And one's plus and one's minus. Okay? So now, what do we have to do? Let's talk about this. How many factors do you see? If you're seeing 2, you're seeing not enough. Okay? Because here's the deal. There's actually 3 factors. That's a negative 1 right there. So I'm going to rewrite that up here and do it. Negative 1, 4t plus 29, 4t minus 29. Okay. Well, negative 1 equals 0. Garbage. Garbage. Or 4t plus 29 equals 0. Or 4t minus 29 equals 0. Okay. Subtract 29. Subtract 29. 4t equals negative 29. Divide by 4. Divide by 4. T equals negative 29 fourths. Remember what t is. T is measured in seconds. Tell me why this is. Listen to this. I love this word. An extraneous root. Means we have to chuck it. It's not good for us. This is impossible. It's a root that just came out from the problem, but it's impossible because that's negative seconds. Negative seconds is not happening. Okay? So now we have to solve this one. So we add 29. We add 29. 4t equals 29. Divide by 4. Divide by 4. We get t equals 29 fourths. Well, now it says to round to the nearest second. So let's see. That's 7 1/4, right? Or I could actually go 7.25 seconds, but they didn't tell me to do that. They said round to the nearest second. I have to listen to directions. Approximately 7 seconds it will take that object to hit the ground. We are finally done with this challenge problem, okay? But we needed to learn a lot more before we got here. Okay, let's take a look at some other examples. All right, let's see. We're going to do a couple problems together, and then I'm going to let you go on your own. So let's look at this first problem. The first thing you got to say to yourself is, what kind of problem do I have? Well, I know I have a nonlinear equation. If it's a 2 or higher, I'm going to set it to 0. This is a quadratic equation. I'm going to set this to 0. So here's what I'm going to do. I'm going to leave myself a little bit more room to write here. I'm going to take this, bring it to the other side. I'm going to take this, bring it to the other side. And now I got z squared plus 6z plus 9 equals 0. That is the first step of solving a quadratic, to set it equal to 0, put it in standard form. Standard form still means it's going to go down, right, in order. 2, degree 1, no z, okay? All right, now we're going to try to factor that. Step 1, look for a GCF. Okay, step 2 can't do, step 3 can't do, step 4, count your terms. There are 3. We're going to make 2 sets of parentheses. We already have our positive leading term. Okay, so plus tells me same as the middle. Z squared can only be z and z. 9 could be 9 and 1, or 3 and 3. I'm going to try 3 and 3. I'm going to check my middle term. Positive 3, positive 3. There's your positive 6z, so I got it. But look at that. It makes no sense to set them both to 0, because I'm going to get the same answer. So I'm just going to set it one of them to 0. And I'm going to get z equals negative 3. Did I lie to you? I told you that if it's a degree of 2, that you're going to get 2 solutions. You did get 2 of them. I didn't say they'd be different. You got 2 of the same solution. Later on, when you take pre-calculus, yes, and I know you will, this is what you would call this. You would call this a solution of negative 3, or a root of negative 3 with multiplicity 2. That means it occurs twice, okay? Because you have to have 2 answers. They don't have to be different, but they have to have occurred twice if that's a 2. If there's one answer, it would have occurred twice if that's a 2, okay? So your answer is only negative 3, but it does occur twice. So I didn't lie to you, I swear. Okay. Let's look at number 2. Number 2, you have to really think about. Sometimes it's important not to just jump into the question, but think about what the goal is. And remember what the goal is. The goal is, when it's not linear, to have factors equal to 0. When it's not linear, when it's not a 1, okay, to have factors equal to 0. Well, these do look like factors, but there's a problem here. This one still is degree of 2, so I still need factors here. So here's what you don't want to do. You don't want to multiply this out, because if you multiply this out, you have terms again. You do not want terms. I have to tell you, you almost never want terms. Terms are harder than factors. There's so many things we can do with factors that we can't do with terms. And for now, we definitely want factors, because then we can use that 0 factor property that says anything times 0 is 0. I almost forgot what it was. Anything times 0 is 0, and then I can make sure that I set each factor to 0. So here we go. We already know this I can just bring down, except I need to bring it down correctly, or I'm going to get it wrong. Then I need to factor this. So it is in standard form, okay? I count my terms. There are 3. I already have the first term positive. I don't have a GCF. I checked for all of that already. Okay, this is a plus. Makes these both minus. 2r squared can only be 2r and r. 18 could be 9 and 2, or 6 and 3, or 18 and 1. Yes, I'm going to check the closest. If I check 6 and 3, then I cannot put the 6 here, because it would have a common factor. So I'm going to put the 3 here and the 6 here. Okay, I'm going to check my middle term. My middle term is 15. This is a negative 3r and a negative 12r. Oh yes, home free, negative 15r. There are my factors. Remember, we said if they're linear, they're not going to be able to be factored anymore, so you're okay. As long as there's no GCF, right? But we would have pulled out a GCF if there was. So we're good. Okay, now where there's 3 factors, we're going to set them each to 0. 7r minus 3 equals 0, or 2r minus 3 equals 0, or r minus 6 equals 0. Okay, here we go. Add 3. 7r equals 3, divided by 7. R equals 3/7. Okay, if you want to put a line here to keep things neat, that's up to you. That could be my straightest line in creation. Or does it just look straight to me? Who cares? Okay, I add 3. I add 3. 2r equals 3. Divide by 2. R equals 3 halves. All right, ready? Add 6. Add 6. R equals 6. 3 answers. If we want to put them in set notation, have a party. 3 sevenths, 3 halves, 6. Why are there 3 answers? Because the degree of this would have been 3. 2r squared times this 7r, if we would have distributed, is 14r cubed. Makes it a cubic equation. That's why we have 3 solutions or roots. They sometimes are called roots. Solutions or roots. Okay? And that's the end of this problem. We have a couple more to do, and then we're going to let you go by yourself. All right, we're back. Here we go. Let's check these out. Okay, they're all a little different, which is I'm trying to show you almost all the ones. Obviously, it's not all the ones you could possibly get, but I'm trying to give you a good random sample here. Okay. Oh, statistics. You should take that too. All right. At any rate, 32x cubed minus 50x equals 0. All right. Let's make sure we understand why we do the steps we do. Since this degree of this equation is a 3, because this is 3 and this is degree 1, okay, remembering how to do degrees of polynomials, okay, it's not as quadratic. It is a cubic equation. Who cares? It's not a quadratic, but it's solved the same way, okay? That's why we're going to do this. If it's not a degree of 1, we have to get everything on one side, 0 on the other, and we have that. So now we're going to factor it, okay? The first step of factoring is to look for a GCF. It's already in standard form. It's real pretty. It's already standard form. The leading term is positive. Everybody's nice. The GCF is 2x, I believe. Let's try that. Divide by 2x. Divide by 2x. And we get 16x squared minus 25. And yes, that was the GCF. You know why I know that? Because there's no more GCF left. Okay. Now, you know what the bummer is? The bummer is we still have a degree bigger than 1. So we still have to try to factor this. And that is factorable. What am I checking for? I am checking for the difference of 2 squares because there are 2 terms. Okay? 16x squared is gotten by 4x times 4x, 25, 5, and 5. Signs are different. Ah, finally. Okay, how many factors do we have? Yes, 37. No. We have 4 factors. Don't forget that 2. Don't forget that 2. So I have, I love this marker. Oh, that's a great marker. 2 equals 0, or x equals 0, or 4x plus 5 equals 0, or I'm going to go into this other land here. It's okay. I spent so much time trying to get that line straight. 4x minus 5 equals 0. Here we go. Ready? All right. 2 equals 0. Garbage. Right? 2 can't be 0. Contradiction. X equals 0. That's okay. Do you see the difference? This has a variable that does not. Okay? Subtract 5. Subtract 5. 4x is negative 5. Divide by 4. Divide by 4. X equals negative 5 fourths. That's another answer. Add 5. Guess what we're getting here? Add 5. 4x equals 5. Divide by 4. X equals 5 fourths. You know why we got opposites, right? Because we had the difference of 2 squares. So of course, we're going to get opposites in my answers. Okay, so there's 3 solutions, 0, negative 5 fourths, and positive 5 fourths. If you'd like, you can put them in a set. You can also write, I'm not sure you're aware of this. I think we might have done this in a mod, but you can write that as plus or minus 5 fourths. Whoa. Oh. 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 Any way that makes you happy. Either in a set notation, not in a set notation, either way. Okay? All right. Ready for number 4? I think I have enough. No, maybe not. Okay. All right, let's take a look at 4. I might have enough space. No, I don't think I do. I'm going to erase this. Okay, let's look at b squared equals 100. All right, I know I have to set it to 0. Why do I have to set it to 0? Because the degree of this is 2. Believe it or not, you're going to get 2 answers out of this. So I'm going to subtract 100, subtract 100. b squared minus 100 equals 0. Okay, now we have to try to factor that. Well, it's in standard form, okay? And if you care, this is for later, but if you care, remember A B and C in a quadratic equation. A is the coefficient of the square term, so A would be 1. B is the coefficient of the linear term. That would be b to the first power. We have no b to the first power, so b is actually 0 in this problem. Who cares? I just thought I'd throw that in. That was extra, cost you nothing. Okay, so here we go. B squared minus 100. Looking for two terms, looking for the difference of two squares. We got it. B and B, 10 and 10, plus and minus. Okay? So B plus, but you've done so many of these now for homework, you're good. B minus 10 equals 0. Subtract 10, subtract 10. B is negative 10. Yes, and you're going to get opposites because it was the difference of two squares. Come on, come on, come on. Plus 10. B equals 10. When you have conjugates, these are not opposites. Remember, they're conjugates. When you have conjugates as your factors, and it's set equal to 0 and you're solving, you're going to get opposites as your answers. So you can put them in set notation if you like, or you can write them as plus or minus 10, whatever makes you happy. Okay? That takes care of number 2. Number 3. Oh, let's take a look. Have to distribute, we don't know what's going on, okay, because this is not equal to 0. And I'm not sure I even want to set it to equal to 0 because we have to talk about what the degree is. It looks like maybe the degree is 2, but there's an x squared on this side and there's an x squared on this side. Watch. You need to simplify. 3x squared plus 3x equals 3x squared plus 3x plus 3x plus 3. Simplifying, 3x squared plus 3x equals 3x squared plus 6x plus 3. Oh my gosh, I don't think this is a quadratic. I think this was incognito. It's hiding. Watch this, okay? There's squares on both sides. I would take care of that first. I got to combine them. Watch what happens. Watch what happens. Good night, x squared. This is no longer a quadratic equation. We have 3x equals 6x plus 3. Okay, why did I put this in there? Because I made a mistake? No, I didn't make a mistake. I wanted you not to go quadratic equation or nonlinear equation solving crazy. I didn't want you to just keep setting things to 0. Don't just, people learn how to do something, just do it no matter what. Okay? This is different. This is linear. Highest degree is 1. Linear. We have to get all the variables to one side, all the numbers to the other. So here we go. This is negative 3x equals 3. X equals negative 1. Done. Done. Now we're done with those 3. I think we have 1 left before you go on your own. All right, here we go. I'm going to solve this one. I just dropped my marker. Hold on. I'm going to solve this one, and then there's the next slide, and the next thing in your workbook has 6 problems on it. I'm going to ask you to go to your workbook and do those, and then we'll come back and solve those. But let's take a look at this one. All right, the biggest error people make is that people start setting each of these equal to 9 because there's factors. Be very careful with that. Just because you have factors equal to 9 does not mean that one of the factors is 9. And if you say that, if you write this, then that's what you're saying. One of those factors have to be 9 so that the product is 9. That's not true. Both of them could be 3. One of them could be 4.5. The other could be 2. We have no idea what they are. So be careful of that. What we have to understand is factors equal to 0 that we want. Now, I have a lot of people who just subtract 9 there. Well, if you just subtract 9, then you're going to get a times 2a plus 3 minus 9 equals 0. We don't have what we need there either because we don't have factors equal to 9. That's a term, and that's another term because of that minus. So the first thing you have to do is be aware of what you have. Right now, I don't know what I have. So I'm going to simplify. Now I'm aware of, equals 9. Now I'm aware of what I have. Now I know I have a quadratic because the degree is 2. Now I know I want to set it to 0. So I'm going to do that now. Don't go setting to 0 crazy. 2a squared plus 3a minus 9 equals 0. Now we have to factor it. We have to count our terms and do all of that. I know you've done a lot of that. So we're going to factor this. There's no GCF. Leading term positive. Here we go. 2a squared, 2a and a. Signs have to be different because of that minus. And 9 could be 3 and 3 or 9 and 1. You know I like to try the closest ones. Let me try that. Okay, here we go. This is positive 3a and negative 6a. Oh, I am so close. Wrong sign, but right numbers. So I'm going to change the signs right now. That's a plus. I didn't mean to change him. I just erased him by accident. Okay, here we go. Now set them equal to 0 because we have factors equal to 0. When we have factors equal to 0, we know one factor has to be 0. So 2a minus 3 equals 0, or a plus 3 equals 0. Okay, add 3, 2a equals 3. Divide by 2, a equals 3 halves. Here, subtract 3, a equals negative 3. So our two answers are 3 halves and negative 3. If you'd like to put in set notation, you can go ahead. Okay, you don't need to, and that's it. Unless your instructor tells you need to, then you need to. Okay, that's number 6 on that last slide in your workbook. Okay, so if you try, these are the first 2 on your next slide. There's 6 there. Try all 6, and we'll come back and we'll solve those. All right, here we go. It was your turn. Let's see how you did. Okay, this first one, we see it's a quadratic because its degree is 2. We're going to set this to 0. I have to set it to 0 because the degree is bigger than 1. Okay, so I'm going to subtract 16x, and I'm going to add 5. Subtract 16x, and I'm going to add 5. I'm squishing a little bit, but I think you can see that what I'm doing. As soon as you move everything to the other side, all they do is change their sign, right? Okay, now I have to factor that. We have standard form. We have the leading term positive. I'm going to make 2 sets of parentheses. Our last sign is positive, tells me the same as the middle, so they're both minus. 3x squared can only be 3x and x. 5 can only be 5 and 1. Okay, so this is negative 1x, and I know you checked yours, negative 1x, negative 15x, which gives me that negative 16x, so I'm good. Set each factor to 0, because one of them has to be 0, at least one. Three x equals 1. Divide by 3. X is 1/3. Okay? Add 5. Add 5. X is 5. So there are your 2 solutions. You know you had 2 because it was a quadratic, degree of 2. Awesomeness. Okay? Hopefully you got that one. Let's check this one. I hope you didn't do extra work here. Okay, 2. What don't you want to do? I hope you're yelling, I do not want to multiply. And the reason that we do not want to multiply is because we want factors equal to 0. We're almost done. The problem is here, this is not linear. We're not done making factors. So we can factor that. So let's do that. Okay, we have 2 terms. We check for GCF no matter how many terms you have, but there's no GCF. Leading term is positive, so that's beautiful. Now we check for the difference of 2 squares. Yes, we have it. So here we go. 9x squared is 3x and 3x. 4 is 2 and 2. 1 plus, 1 minus. Awesome. Okay, now we're going to solve this. Set them all equal to 0. Okay, add 1. 3x equals 1. Divide by 3. 1/3. So that's one of my answers. Okay, number 2. Subtract 2. Subtract 2. 3x equals negative 2. Divide by 3. X equals negative 2/3. That's another one. Final answer. Add 2. 3x equals 2. Divide by 3. X equals 2/3. And again, you can put this in set notation. X equals 2/3. So 1/3, negative 2/3, and positive 2/3 is my answer for that one. There's 3 answers. Guess why? Because 3x times 9x squared is 27x cubed, which makes it a cubic equation, and therefore getting 3 answers. Okay, so that was the first 2. Let's do the third one. Okay, step 1. Well, first of all, we have to figure out what we're doing. It is a quadratic equation because the degree is 2. So since the degree is 2, we want it set to 0. Thank you, they did that for us already. Now we have to factor. First step of factoring is GCF. Yes, we have a GCF. It's 3y. 1 set of parentheses, remember what a GCF. We divide by 3y. And we get 2y plus 1. Okay, now we set our factors to 0. How many factors are there? Yep, there are 3. 3, the y, the 2y plus 1. 3 equals 0, or y equals 0, or 2y plus 1 equals 0. Okay? 3 equals 0, garbage. 3 can't be 0, contradiction. Contradiction can't be 0. Y equals 0, oh, look, I'm happy. It's done for me already. Absolutely done for me. Okay, subtract 1. 2y equals 1. Negative 1, sorry. 2y equals negative 1. Divided by 2. Y equals negative 1 half. And now we're done. 2 solutions, quadratic. Awesome. Okay? As soon as I get these off the board, we'll do the next 3. All right, last 3. Let's see how we did. 18x squared, we know it's quadratic. We have to set it to 0. So we get 12x plus 2 equals 0. Okay? Now we look for a GCF. Our leading term is positive, so we're good with that. Our GCF is 2. Remember GCF, we make one set of parentheses, and we get divide by 2, and we get 9x squared plus 6x plus 1. Not done. We still got a quadratic in there. We got to check if it's factorable. Okay, there's no GCF. We took it out already. I'm going to bring it down. Okay, 9x squared is 3x and 3x, or 9x and 1x. 1 is 1 and 1. Okay, so I'm going to try 3x and 3x. I know my signs are positive. They're the same, and they're positive. 1, I have no choice. Check my middle term. Positive 3x, positive 3x. That gives me that positive 6x. We're good. Here we go, setting each factor equal to 0. 2 equals 0, or 3x plus 1 equals 0. Or, well, yeah, that's nice, but I'm not going to solve this again because I know it's the same answer, right? It's that one where we get that same root twice. 2 equals 0, garbage. Subtract 1, subtract 1. 3x equals negative 1. Divide by 3, divide by 3. X equals negative 1/3. Okay, so my only answer is negative 1/3, but I know we're supposed to have 2. We do. It occurs twice, or it's of multiplicity 2. You will sound so smart if you say that. Of multiplicity 2. Okay, there we go. 5. That looks so small, doesn't it? X squared equals 49. What we want to do here, because it's not linear, it happens to be quadratic, but 2 or higher, we want to set this to 0. So we're going to subtract 49, subtract 49. X squared minus 49 equals 0. We're going to try to factor that. We don't have a GCF. Our leading term is beautiful. Okay, 2 terms, going to check for the difference of 2 squares, and yes, I got it. So I hope you did all of that. Now you're all looking like, I didn't do that, but I just knew. Okay, x squared, x times x, 49, 7 times 7. Set them all as 0. 0 factor property tells me so. If I asked you why you're doing it, could you tell me? 0 factor property tells me so. If I have a product that's equal to 0, at least one of the factors must be 0. That's what I know. It makes sense if you think about it. Subtract 7. X equals negative 7. So we have 7 and negative 7. That should be good. 1 left. 1 left. Here we go. All right, again, for many reasons, I just want to simplify this first so I can see what I have. 10x squared minus 13x equals 3. Subtract 3, subtract 3. 10x squared minus 13x minus 3 equals 0. Looking for a GCF? Okay, leading term is positive. That's good. There's 3 terms. I got to make 2 sets of parentheses. My last sign is negative. It tells me that they're different. So plus, minus, 10x squared could be 5x and 2x, or 10x and 1x. 3 can only be 3 and 1. Okay. 5x and 2x. I'm going to try 1 here and 3 here. Now let me try this out. Positive 2x, negative 15x gives me that's negative 13x, right? But you check that. 5x plus 1 equals 0, or 2x minus 3 equals 0. Okay, subtract 1. Heading home, 5x equals negative 1. Divide by 5. X equals negative 1/5. Done there. Here, add 3. 2x equals 3. Divide by 2. X equals 3 halves, and that's it. There's your two solutions from this quadratic. Absolutely awesome. So that's how you solve quadratics or any non-linear equation whose degree is 2 or higher. We just happen to have a name for the quadratics. We have a name for the cubics too, but they don't occur that readily, okay, in this class. Okay, so next time we're going to be doing applications of quadratic equations. What a thrill for you.